we're going to talk about absolute value functions and dilations. Warm up. Write the equation of the function y equals 7x if it is shifted up 3 units and to the right 4 units. So in this particular problem, our equation is y equals 7x, our parent function. So we're going to write y equals 7, and then since there's a left or right shift, we'll write parentheses. The only thing that goes inside the parentheses is the x and the left or right shift. So here it's right 4, and right is opposite of what we think, so right will be minus 4. And then the function shifts up 3 units. Up is outside the parentheses, and it's what we think, so plus 3. So there's the equation of the shifted function. B, if the parent function is y equals f of x, how do the following transform the function? So we have y equals negative f of x, where the negative is on the outside of the function. So if it's on the outside of the function, that's a reflection over the x-axis. Now, if you were unsure, you could pull up Desmos and just type in a parent function. So I'll show you what to do if you forget these reflections. So let's say I'm just going to look at a quadratic. So y equals x squared. There's the parent function. To see what happens if there's a negative on the outside, I will put a negative on the outside of the x squared, and we can see, yep, it's a reflection over the x-axis. So it flips it upside down. So it's over the x-axis. You can say that it's a vertical flip. You could also say it's upside down. All right, so there's an example of when the negative is first in front of the function. And the way that I remember it to flip over the x or upside down is x comes before y, like the x-axis comes before the y-axis, and here the negative is coming first instead of inside the parentheses. So when it's inside the parentheses, I think, hey, the negative's coming second, like the y-axis, like y comes second after x. So that would be a flip over the y-axis. Okay, so second, so this is flip over the y-axis. We can call it a horizontal flip. And again, to show you a picture of what that looks like, I would just type in a parent function. Here's x squared, and then I would put in parentheses the negative x squared, and oh, this one's hard to see the vertical flip because it's a mirror image, so let me actually pick a different function. Let's do the square root function. That one's hard to see the horizontal reflection. All right, so let's do the square root of x. Okay, so square root of x. All right, so let's say that's the parent function. And now let's do the square root of negative x. And we can see more clearly in this example how it does flip over the y-axis. The y-axis is straight up and down. So again, use Desmos to help you if you forget the different translations or reflections of a function. Okay. So again, review, sketch the following. Let's say that this blue-looking curve is our original function. Let's draw or sketch the reflection. So again, if the if the negative comes first, this is the flip over the x-axis. So a vertical flip. So here's the x-axis. So here's what our first function would look like. I'll call this function A. I'll call my next one function B, and again here the negative comes second, so it's a flip over the y-axis. Okay, so we're going to take a look at, again, go to the original function. Here's the y-axis, so here's what my graph B looks like. And then if it's a flip over the x and over the y, I'll call this graph C, and you can go any direction first. So I'll go over the y, over the x. Either way, it's going to end up right here, so there's graph C. So again, if the negative comes first, it's a flip over the x or a vertical flip. If the negative comes second, it's a horizontal flip or flip over the y. And then if you have the negative in front of the function and in the parentheses, it's a flip over both, and it's kitty corner from the original, or diagonal from the original. So as we've been exploring a new parent function every day. Our new parent function today is the absolute value of x. So again, we're going to start with the table, and we'll talk about domain and range of this function, and then we'll take a look at how different shifts play out in this particular parent function. So absolute value of x is distance from 0. So I'm just going to pick some values here. Oops, let's go negative 3, -2, -1, 0, 1, 2, 3. Let's graph this function. So again, if you didn't have a graphing calculator and you wanted to graph a function, you can pick values and plug in. So the first one is y equals the absolute value of -3. That means what's the distance of -3 from 0? And that would be 3 units. For plugging in -2, what's the distance of -2 from 0? And that is 2. And here's all the distances. If we plug in a 1, what's the distance of 1 from 0? It's 1. 2 is 2 away from 0, and 3 is 3 away from 0. So let's see what these coordinates look like when we graph them. So the first point would be at -3, 3. Then we have -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. So if we take a look at this looks kind of like our parabola, but instead of a parabola, it's going to be a V-shaped graph. So here's our parent function for today, the absolute value of x. If you want to describe the shape of this graph, it's V-shaped instead of U-shaped. So it does bend back up because the distance of negative numbers from 0 is positive. So if we talk about domain and range, domain is all the possible x values, and you can see it goes all the way left and all the way right. So we say that for the domain it's x values, x are all real numbers. The range, there is a lowest value here. So here y equals 0, there's the lowest value. So for a range right here, we say y is greater than or equal to 0. So there's domain and range for our absolute value function, unless, of course, it's shifted. All right, so let's take a look at using Desmos to figure out different shifts of the graph. And so it kind of tells you you have to use the keyboard thing to get the absolute value sign, so there it is. So it says make and write down your predictions on how the following function will be shifted. And so we know from previous sections that if the +2 is on the outside, that typically means up 2. So let's graph that and see if our prediction is correct. So I'm going to just type in the parent function. Again, the parent function would be y equals the absolute value of x, and here's that absolute value with the 2 lines in the A. So there's your parent function, the V-shaped graph. Let's see what happens if we add 2 to that. And we can see, yes, it does shift up 2 units. And so if you made that prediction, you'd be correct. How about if it's inside the absolute value and it's -3? So my prediction for that would be to the right 3. Again, we can test that by putting inside the absolute. I'm just going to adjust this one. Okay, so this one, x -3, and we can see, yes, it does shift to the right 3. And so you can see how you can use Desmos to check prediction. Here there's 2 shifts. So the +1 inside the parentheses does mean to the left 1 unit, and the -2 on the outside does mean down 2. So those shifts are the same as before with our other functions that we looked at. So again, outside the parentheses, up or down, inside, left or right. All right, so the vertex of the absolute value function, the vertex is where it changes direction. So if we look at the original function, like a parabola, like a quadratic, it changes direction at 0, 0. So again, it's going down, and then all of a sudden at 0, 0, it starts going up. So that's called the vertex. So our vertex of this function right here would be 0, 0. Let's talk about what happens if we make the shift here. And again, inside, it's opposite of what you think. So this is left 2. So if we move everything left 2, the vertex also moves left 2, so that would be -2, 0. Again, if you were unsure, you could test it out by doing x + 2, and we can see that vertex is at -2, 0. So use Desmos to help you if you're unsure of the new vertex of the graph. All right, this graph does shift left 3, down 4. So our vertex would be -3, -4. Our next function, this graph shifts to the right 1 and up. And so our new vertex would be right 1 would be +1, up 2 would be +2. And let's take a look at our last one. Our vertex here would be to the right 4 and up 3. And so if it's to the right 4, that would be 4 up 3 would be +3 right here. And so if you notice, the left or right shift in the vertex, they're always the opposite of one another. So this is +2, but it was left 2. So the graph shifted left 2, so minus 2 was the vertex. Here was plus 3, this is minus 3, this is minus 1 plus 1, minus 4 plus 4. And so in general, the vertex is going to be the opposite of the h value. So opposite of h. The k value stays the same because up and down is what we think for the direction. So there's a pattern for the vertex, opposite of h, but k remains the same. So the new part is we're going to take a look at something called dilations. We're going to take a look at the a value of the graph, which is the number in front of the parentheses. So if you take a look at the number in front of the parentheses, we have taken a look at this number before. In a linear equation, the number in front of like the parentheses with the x in it is the slope. And so we don't call it the slope in nonlinear functions, but we do call it the a value. So another way that you see this written out for linear functions is y equals ax plus b, and that a translates to the slope in functions that are not linear. So it says use your calculator to graph the following, and again we're looking at dilations, and I'll explain why in a second. It says don't sketch yet, we'll do that together. All right, so let's type all these in and see what happens to the parent function. So again, there's my parent function. Let's type in a negative. And you can make a prediction what that negative on the outside of the absolute value is going to do because we've looked at that behavior before. So there it is. You can see that, hey, that x comes first. It's going to, or the negative comes before the x. It's going to flip it over the x-axis. What happens if there's a negative 2 in front? So we haven't looked at that before. So y equals negative 2 and then absolute value of x. And if you look, it's still flipped over the x, but it's narrower, it's skinnier. And here's why I was talking about slope. If I were to graph this, it's kind of like graphing a slope. I'm going to start at the vertex. If I go down 2, because here's the negative 2, down 2 over 1, I get to the next point. Down 2 over 1, down 2 over 1. So this value is like the slope, except we're going to go down 2 to the left 1 as well, down 2 to the left 1, down 2 to the left 1. So it's like the slope. It compresses the graph. This negative 2 right here makes it skinnier than the original. Let's talk about if this one right here, the negative x plus 1 inside the absolute value plus 2. What happens there? Whoops, I don't do that. Okay, so y equals, and I forgot the function already, negative absolute value of x plus 1, and then it was plus 2. Okay, so this blue graph, it does shift it left 1 up 2, but again, that a value, this number in front is negative, so it flips it upside down. Or in other words, we can talk about like what the slope would be. It's going to go down 1 over 1, down 1 over 1 to get to the next point, and we're going to do that on both sides. Let's take a look at the last one, and then we'll talk about graphing it. It's 1/2, and then it's the same equation as above, so 0.5 is 1/2. I'll just type in 1/2. So y equals 1/2 absolute value of x plus 1 inside the absolute value plus 2. So this is just like the blue graph, except there's a 1/2. I'm going to get rid of some of these right here just so we can look at the difference. Oh, I wonder if I can undo that. I want to get rid of all those. Okay, here are the ones I want to get rid of. Okay. Did I want to get rid of that? Oh, did I want to make it 1/2? Yes, okay. All right, so the blue graph was the one we just typed in that was negative. This one, the only difference between the blue and the green graph here is the 1/2 or the negative 1. And so the 1/2 is positive, so it is going upwards. And again, if you look at the 1/2, it's wider than the original because the slope or the a value here, not really called slope, the a value, is 1/2. So it's going to go up 1 over 2, up 1 over 2. And then you're going to do it in the other direction as well. All right, so again, that number in front is called the a value, and it's like the slope. Again, let's graph it. Okay, so the original, I'm going to try to use color here. So I'll make my original purple. And so it's negative 1/2 x. So right here, we're going to start at 0, 0, and the slope is negative 1. So down 1 over 1, down 1 over 1 in each direction. So there's that first graph. It's just flipped over the x-axis. It's like having a slope or an a value of negative 1. So again, we have y equals a times the absolute value of x. A is just that number in front of the x. All right, let's go over the next one. I'll make this graph, I don't know, blue. It's a negative 2, so the a value is negative 2 here. So I'm going to start at the vertex, it doesn't shift, and I'm going to go down 2 over 1, down 2 over 1, and you can see that this graph's skinnier because the slope is steeper. So down 2 over 1, I'll go in the other direction, down 2 over 1. All right, so that one is skinnier and upside down. right here, let's do the shifts first. So the +1, +2 is left 1, up 2. So I'm going to graph that first. Left 1, up 2, there's my new vertex. But now we have this negative in front, so the slope, I'll call it slope, I should say A value. A is -1. So what that means is from our vertex, we're going to go down 1 over 1 in each direction. And then we're going to make our graph. Okay, and then our last one here, again, same shift as before, that left 1, up 2. So I'm going to start in that same spot. But now our A value is 1/2, and it's positive. So I'm going to start left 1, up 2. So there's the red dot. And instead of going down 1 over 1 like I did for the last graph, this one's going to go up 1 over 2 because the A value is 1/2. So up 1 over 2 in each direction. And there's what my graph looks like. So what happens to the graph when there's a negative in front of the absolute value? So when the A value is negative, okay, so we know that that slope, I'll put slope in parentheses because I don't think it's really called slope, is negative. So our graph is upside down. Graph is upside down. Okay, what happens to the graph when you multiply by a number bigger than 1? All right, so if it's bigger than 1, then our graph is going to be, let's see, where it's bigger than 1. Okay, so here the absolute value of this is bigger than 1. So 2 is bigger than 1, and that is when our graph is skinnier. So this is like our slope. So when the absolute value of A is bigger than 1, so -2 is smaller than 1, but if you look at the absolute value, it's bigger than 1, and this is going to be skinnier. So like the blue graph is skinnier than the original function. What happens to the graph when you multiply the A value is smaller than 1? So this is like our 1/2 right here, and we saw that that 1/2 is going to be fatter or wider than the original. So this one is going to be fatter or wider than the original graph because we go up 1 over 2 instead of up 1 over 1. So let's take a look at how that plays out, and then you'll have time to practice these ideas. So for the following examples, the parent function is, again, the absolute value. G of x equals the absolute value of x. So this is your V-shaped absolute value graph, so V-shaped absolute value. Okay, so let's circle what's true about this graph right here. So we know that this graph goes left 1, up 6. I'm looking for left 1, up 6. And here's our -3. The A values, the absolute value of -3 is 3. And 3 is greater than 1. And so if it's bigger than 1, we know it's going to be skinnier. It's steeper or skinnier. So we're looking for up 6, left 1, skinnier than the original. So left 6, up, left 1, up 6, skinnier than the original. Oh, and it is upside down because of the negative. So it's going to be B right here. So there's all the different translations of the graph of h of x. All right, let's take a look at this one right here. This one just goes down 2. And our absolute value is less than 1, so this is going to be fatter than the original. And it's positive, so it's not going to be upside down. So it's going to be down 2, and it's going to be fatter than the original. Do I see this? Down 2, skinnier. So I guess I don't have the right answer here. This is going to be down 2, so we'll cross this out. It'll be down 2, but fatter than the original. So I apologize for my typo. All right, so today the main two new things was, number 1, the absolute value graph. Here's the parent function. The vertex is at 0, 0. The A value is 1, so we're going to go up 1 over 1 to get to each of the coordinates. The second thing was the A value. We know the up, down, left, and right shifts. Those remain the same. So the A value, this number in front of the absolute value, if it's bigger than 1, it's going to be skinnier. And again, we're looking at the absolute value of that number. So you look at the positive value here, the -2 is 2. Bigger than 1 is going to be skinnier. If the number's less than 1, like the 1/2, it's going to be fatter than the original or wider because it's less steep. This one's steeper, so it's skinnier. This is less steep, so it's fatter. All right, so your assignment then is the next 2 pages. Again, I do post the answer keys. You should definitely check your answers. So it's 47 to 48. Okay, so work on that and let me know if you have any questions.